So now let's do the next question. Find the value of ZL for maximum power transfer in the network. Also find the maximum power. So this is the circuit over here. Then here is the load impedance. So we just, whatever the question is, just simply follow the standard procedure. Okay. So here in the circuit, this is a Western bridge, right? But we are not. But we are just. But here, this equation to do is very simple. Once again, over here, let me remind you that they have not given you the load impedance, right? They haven't told what kind of a load impedance it is. They haven't told you whether it is the variable resistance or a variable resistance with a variable reactance or a variable resistance with a fixed reactance. So therefore, you can assume that this is a variable resistance with a variable reactance. Okay. So in that case, which means whatever the source impedance you are getting, just simply take the complex conjugate of that. That's all. So let's do this question. Okay. So here, as usual, we are going to apply the Thevenin's theorem on the circuit to find the Thevenin's equivalent, which means the first step is you remove the load. So let me remove the load. So to find, let me use another pen. To find VTH. Okay. To find VTH, I have to remove the load, and the open voltage across these two terminals is VTH. So therefore, okay. This is 10J, this is 5 ohm, this is 7 ohm, this is minus 20J ohm. Okay, and I have removed the load from here, so therefore this is the open voltage, and the voltage across this is VTH. Okay, the voltage across is VTH. Alright, so how to find the value of VTH over here? To find the value of VTH, there are very easy ways of finding VTH. Okay, one way of that, if you want, you can assume that this is mesh 1, this is mesh 2, and this is mesh 3. But remember, mesh 3 is not a mesh, it's simply a here the value of I3 is equal to 0. Okay, you can assume like that, or you can simply assume that the voltage over here, the voltage VTH is nothing but the voltage across the inductance 10J and the voltage across the minus capacitor minus 20J. It is a voltage across these two elements. Voltage across these two elements is the value of VTH. You can do this problem by assuming like that also. Any way you want, you can do it. Okay, this is I1. Okay, this is I2. This is I. For I, we need to mark. It's very important to mark the positive terminal as well as the negative terminal. Okay, you need to mark the positive terminal as well as the negative terminal over here. Okay, so what is the value of VTH? Like I said, VTH, you see, this is the current, right? And it's okay. We will. I mean, one thing, I will just assume that I would apply this as mesh 3. Okay, so that you won't get any confusion. Otherwise, it will be very difficult for you to understand how I got that equation. All right. So let me do this problem, assuming that this is a mesh 3. Okay, open mesh, but assuming that the value of I3 is equal to 0. Okay, I will do this problem like that. So in that case, this is mesh 1, this is mesh 2, this is mesh 3. Okay, so therefore equation for mesh 1, right? What is the equation for mesh 1? Here you can say that I1 is touching only these two elements. I2 is not touching any elements in mesh 1, right? I2 is not touching any elements in mesh 1, but I3 is touching this equation, right? So which means we have I1 into 5 plus 10J. I1 into 5 plus 10J. Then you can write minus I3. If this is I3, you can say minus I3 to 10J. But I'm not going to write minus I3 to 10J because we already know that I3 is equal to 0. Okay. So therefore, this is equal to, now what is the voltage source? 100 volt, right? 100 is the voltage source, and is it plus 100 or minus 100? Look at the direction of the current I1. I1 is flowing in the clockwise direction, which means in this branch I1 is flowing from left to right. It is flowing like this, from left to right it is flowing, right? It is flowing in the clockwise direction, which means this positive terminal is generating I1. This positive terminal is generating I1, which means this voltage is supporting I1. Therefore, it is plus 100. Okay, this is the equation for mesh 1. Therefore, I1 is equal to 100 by 5 plus 10J. This is the equation for I1. Or I can also say this is nothing but, let me see, if it's divisible by 5, then it becomes 20, right? 20 by 1 plus 2J, correct? 20 by 1 plus 2J. If it is divisible by 5, both the numerator and denominator is divisible by 5, right? So this is the value of I1. Okay, so now I found the value of I1. Now what is the value of I2? That is the equation for mesh 2. Equation for mesh 2 is, this is the equation, right? So therefore we have I1 is not touching any elements in mesh 2, right? So therefore it is I2 into 7 minus 20J, okay, minus I3 into minus 20J. You can write like that, but I'm not going to write like that because I'm already saying that I3 is equal to 0. This is an open mesh. So therefore I3 is equal to 0. So therefore this is equal to, and what about the voltage source? This I2 current is going in the clockwise direction. So in this branch it is going from left to right. It is going from left to right, right? This is going from left to right. So therefore this current is flowing into the positive terminal, right? The voltage source, the positive terminal of the voltage source is supposed to generate current, but here it is opposing the current. So therefore it is minus 100. So therefore I2 is equal to minus 100 by 7 minus 20J. This is the value of I2. This is the equation for mesh 2. So therefore what is the equation for VTH? Equation for VTH. Equation of VTH. Okay, this time just for your understanding, okay, you don't have to write like this. For your understanding, I will assume that there is a current called I3. Okay, just for your understanding. So in that case, then what is how do you write the equation for this mesh? Here it is I1, right? So we have, and here this is like writing the equation for mesh 3. Therefore I1 and I2 are considered as negative. So therefore minus I1 into 10J, okay, minus I2 into minus 20J, okay, minus I2 into minus 20J, and plus I3 into I'm not supposed to write like this, but just for your understanding only I'm writing like this, plus I3 into 10J minus 20J, 10J minus 20J, then you have plus VTH, right? Plus VTH is equal to 0. Plus VTH is equal to 0. This is the equation for mesh 3. Okay, this is the equation for mesh 3. This is the equation, but like I already told you, it's an open mesh and I3 is equal to 0. Therefore we have minus I1 into 10J plus I2 into 20J plus VTH is equal to 0, or in other words VTH is equal to I1 into 10J minus I2 into 20J. This is what I meant when I said that the voltage across VTH, right? The VTH is equal to voltage across this inductor plus the voltage across this capacitor. That is exactly what you're seeing here. Voltage across the inductor plus voltage across the capacitor, right? This is another way of writing the, what I meant is like this. That is I1 into 10J is the voltage across the inductor plus I2 into minus 20J is the voltage across the capacitor. Okay, this is what I meant. So you can either learn to write in this format directly. That's always better, right? Instead of doing this long cut method, apply the shortcut method. Okay, if it is possible, but still I would rather have you not make any mistakes. Okay, so now I found the value of I1, I found the value of I2, so I can substitute the value of I1 and I2 over here. So what is the value of I1? It is 20 by 1 plus 2J. 20 by 1 plus 2J into 10J, okay, minus, and what about I2? The value of I2 is minus 100 by 7 minus 20J. Minus 100 by 7 minus 20J into 20J. Okay, minus of minus becomes plus, so we have this equation as, over here it is 200J, right? 200J by 1 plus 2J minus, and it becomes plus, sorry, minus of minus is plus, and here you have 2000J by 7 minus 20J. This is the equation, or this is the value of VTH, or in other words, let me see. First 200J by 1 plus 2J. Let me write that. $200J divided by, so no need on bracket, this bracket is not enough. 200J divided by, again bracket, 1 plus 2J. 1 plus 2J, close the bracket, okay, close the bracket again, plus, open the bracket, 2000J divided by bracket 7 minus 20J. 7 minus 20J. Close the bracket and close the bracket again. This is the value, and you get minus 9.087 plus 71.18J. This is the value of VTH. Or if you're writing in polar form, it is, let me see, is 71.758 angle 97.275 degree volt. This is the value of VTH. Okay, this is the value of VTH. So now I'm going to find the value of ZTH, right? So to find the value of ZTH, as usual, this is a voltage source. This is the only voltage source over here. Okay, so I'm going to short it, and after shorting it, I'm going to find the impedance across these two terminals. So my circuit is, to find ZTH, ZTH is the impedance across A and B over here, right? Here we have 5 ohm and 7 ohm, and here you have 10J and minus 20J. 10J and minus 20J, and here you have a voltage source, and if you, to find ZTH, if you see any voltage source, you should short it. So I will short it like this. Okay, so now we need to find the equivalent impedance across A and B. So now how to find the equivalent impedance across A and B over here? Like I said, okay, find any two elements which are either in series or either in parallel, which of them, right? So let's see in this example, okay, if you take this example, I don't know if these two elements are in series or parallel. I also don't know if these two elements are in series or parallel. But what about these two elements over here? What about these two elements? See, look at this end of the resistor and look at this end of this inductor. Both of them are having the same joint, right? Having the same connection over here, same junction. And what about the end of this resistor and the end of this inductor? Here also see both of them are having the same connection, which means these two elements are in parallel to each other, right? These two elements are parallel to each other because they are both ends are having the same connection. See, this end of the resistor and this end of the inductor is the same connection over here, and this end of the resistor and this end of the inductor is also having the same connection. Therefore, these two elements are in parallel to each other. In the same way, these two elements are also in parallel to each other because one end of the resistor and one end of the capacitor is connected to the same junction, right? Same junction. That junction is called as B. This junction is called as B and this junction is called as A. This is A, this is B. So both of them, both these two ends are having the same joint, and these two ends are also having the same joint. It means this end of the resistor and this end of the capacitor is also the same, as having the same connection. Therefore, these two elements are also parallel. So therefore, these two elements are in parallel, these two elements are in parallel. Let me draw and show it to you. What I meant is like this, that is this circuit, if I want, I can simply, this is the problem is in visualizing the circuit. I want all of you to be an expert in that. This is what I meant. This is how the circuit is. This circuit and the previous circuit both are the same. This is the 5 ohm, this is the 7 ohm, this is the 10J, and this is that minus 20J. This circuit and this circuit are both the same. Both the same. They are both exactly the same. So which means these two elements are in parallel, these two elements are in parallel. So I'm going to combine these two elements and then I'm going to combine these two elements. So what will happen if I combine 5 parallel 10J is equal to 5 into 10J by 5 plus 10J, which is equal to 50J by 5 plus 10J. This is the value of this impedance. And what is the value of this impedance? It is, that is 7 parallel minus 20J. 7 parallel minus 20J is 7 into minus 20J by 7 minus 20J, which is equal to minus 140J by 7 minus 20J. This is the equivalent impedance of these two combination, which means the total impedance is like this. If I combine these two elements, this is one impedance, this is the other impedance, and this is ZTH. Okay, so this impedance is 50J by 5 plus 10J, and this impedance is minus 140J by 7 minus 20J. So therefore, what is the value of ZTH? ZTH is equal to 50J by 5 plus 10J minus 140J by 7 minus 20J. This is the value of ZTH. Okay. Therefore, that is 50J divided by 5 plus 10J. I forgot to put bracket over here. By putting the bracket, you should be very careful about this. Okay, when you're doing the calculation, you should be extra careful. Be very certain what you're typing inside the calculator. So this is the first term minus the second term. Minus the second term is 140J divided by 7 minus 20J. Close the bracket, close the bracket. Okay, this is the second term. Let me check again. This is the first term, and you will get the answer as 10.236. 10.236 minus 0.183. 0.183 J. This is the value of ZTH. Okay, this is the value of ZTH. If you want, the polar form is not required, only this is required. So therefore, what is the circuit looks like? The circuit is consisting of a voltage source. Okay, you can either call it as Vs or VTH. What is the value of it? Let me check. Value of VTH is this one, right? 71.758. VTH is equal to 71.758 angle 97.275. This is the value of VTH. And as for your impedance, ZTH is equal to 10.236 minus 0.183J. This is the value of ZTH. So therefore, now I can tell you the value of ZL. That is, I am already assumed that this impedance is having a variable resistance with a variable reactance. So therefore, in that case, according to maximum power transfer theorem, ZL is equal to the complex conjugate of the source impedance, which is ZTH. Therefore, ZL is equal to 10.236 plus 0.183 J ohms. This is the impedance. This is the value of the impedance. Or in other words, let me just make this let me just make the conjugate of this answer. Okay, then I will convert this to polar form. It is 10.238 angle 1.022 degree ohms. This is the value of ZL. Okay, so now I'm going to find the maximum power. So to find the maximum power, which means maximum power is achieved only when ZL is also equal to 10.236 plus 0.183 J, right? So which means to find the maximum power, I need to find the value of IL, or I need to find the magnitude of IL, right? So so P is equal to magnitude of IL the whole square into RL. And what is the value of RL? RL is the value of the resistor. What is the value of the resistor over here? The value of the resistor is the real part, 10.236, because there is no J over here. So definitely this is not a capacitor or inductor, this is a resistor. So 10.236, the value of RL is equal to 10.236. And what is the value of IL that I need to find? So IL, if you are applying mesh analysis, IL into ZTH plus ZL is equal to VTH, right? This is equal to VTH. Okay, and this is the value of VTH. And you see, if ZTH plus ZL, if I add these two elements, both the imaginary part will cancel each other. So you will have only 10.236, right? 10.236 plus 10.236. So therefore IL is equal to, what is the value of VTH? I'll write it complex number, so I'll get the more accurate answer. That is minus 9.087 plus 71.18 J, 71.18 J divided by 10.236 plus 10.236. What is 10.236 plus 10.236? It is 20.472. So this is 20.472. This is the value of IL. Okay, this is the value of IL. So therefore, bracket minus 9.087 plus 71.18 J, close the bracket, divided by 20.472. 20.472. Okay, divided by 20.472, and you will get minus 0.444 plus 3.477 J. Okay, this is the value of IL, but I am only interested in finding the magnitude of IL. And what is the magnitude of IL? Take the option, find this polar form, remove the angle, that is 3.505. So therefore magnitude of IL is 3.505. Okay, the magnitude of IL is just simply take this is their polar form. So this is the value of R angle theta. R is equal to root of A square plus B square. That is this R, that is 3.505. So magnitude of IL is 3.505. So now I found all the values. So now I can simply find the value of power. Power is equal to, that is, value of IL is 3.505 the whole square into 10.236. Okay, let me see. 3.505 the whole square into 10.236. 10.236. This is the value of power, which is 125.75 watts. This is the value of the maximum power. You will only get this maximum power when the load impedance is equal to this value. And this value is nothing but the complex conjugate of the source impedance. Okay.